Oh, hi. So ratio tests. So here we're going to consider a series, any series, positive terms, negative terms, doesn't matter. And we're going to calculate this funny thing L. So it is, what do? You take a term, you divide it by the preceding term, and then you take absolute value, and then you take the limit of that expression as n goes to infinity. And you call this L. Okay, so L, assuming it exists, limits don't always exist, will be bigger than 1, less than 1, or equal to 1. Okay, so if it's bigger than 1, if it's bigger than 1, then the ratio test tells us that the series diverges. Okay, it's some, I don't know, it's hard to see, the proof illuminates a little bit, but it basically gives us some measure of what's happening to these terms here, an. You know, are they descending? Are they approaching zero fast enough for this series to converge? If L is less than 1, then this series does converge. If L is equal to 1, that's the bad situation for a student because you've wasted your time. Okay, you are gaining nothing from this ratio test that you performed. Okay, let's try here. Hope for the best. So I'll remind you of the convention I use when I write nothing here and here. Okay, what I mean is n equals 1 to infinity. But for ratio test, you know, n is going to infinity when I calculate this L, so it doesn't really matter. It doesn't matter what number I put here. It's not going to affect the outcome, because we're just trying to determine whether the series converges or diverges. And, you know, the first 25, 26 terms don't affect that outcome. Okay, let's find this L in this case. So we want a n plus 1 all over a n. So a n plus 1, which is worth writing. So what you do is you take this expression here, and everywhere that you see an n, you replace it with an n plus 1. So right off the bat, this n is becoming n plus 1. And then you get your half still, and then we'll have n plus 2 up top. Is that visible? Yeah. So that's what ends up in our numerator here. So again, we have an plus 1 divided by an. You'll notice this is exactly this. Okay, then we do some fancy simplification. I'm going to put, you know, these two factors together, and I'll put the factors involving a half together. There's nothing negative here, so I'll just drop the absolute value. And for these two, they have the same base, so I can subtract the exponents. Give me just 1. So this one here is, you know, the one right there. Okay, now I can perform the limit. Okay, the half is simple. Don't need that 1 there. Burp, burp. This expression is just going to 1. Okay, again, you imagine 1,000,000 plus 1 divided by 1,000,000. It's very close to 1 and getting closer. So I get just half for this. Then I go back to my ratio test and I say that I am falling into this category here. Okay, so I can apply a ratio test. And it tells me that the series is convergent by ratio test. So I should say it like that, just to indicate clearly to my reader what I'm doing.